Okay, so we said we want to know, estimate the speed at 25 seconds, was it? So if I go up from 25 up to that point, now what I can see is that the distance that I am at after 20, or the fish is at, is what? That's 11, so it'd be 11.8 meters. Okay? So we know the fish has travelled 11.8 meters in 25 seconds. That's what I can read from a distance time graph. Right? When I asked you for what was the average speed between 10 and 20, was it? What did we do? We went up to that point and we went to 20 and we looked at the change in distance and the change in time. Do you notice that? So how do I write the change in distance?
Delta.
So delta distance and delta time. Well,
That's big delta.
that's big delta, yeah. So we've got delta D. So we've been using, instead of that, we've been doing
What's the difference?
just capital and small ones. That's all. Capital delta, lowercase delta. Now, do you see how to get from looking at those points, we've calculated an average, because actually what we've done is worked out rise over run, distance over time. Do you see that? So we've worked out the gradient between those 2 points as if it was a straight line. Do you see now why the question says work out the average speed? Because it doesn't actually do that speed. We've kind of estimated it by drawing a straight line. But we have done the gradient between those 2 points. Now, if I wanted to know the speed at a particular point, so rather than the speed between 2 points, what do you think? How could we do it? So that's the point. That's the point I'm looking at. Any idea how you could find the speed at a particular point? Hang on a minute. Say what? Sorry.
Well, speed was distance over time, so you don't just we're going to do this in any time.
But I could do an average of all of that, but that's not really the speed I'm going at that moment. That would be an average. An area of... That would be distance times time. If I worked out the area.
Would you do the line thing on there?
So what's it called? So if I've got 2 points and I find the gradient between 2 points, but if I want to find it at one particular point, I would have to find the gradient at one particular point, and that's by doing the, what's it called? Anyone remember? Are you meaning put a line, kind of like a straight line, yeah?
And the tangent?
The tangent, mate. I knew someone would get it. So if I did that line like that, so there's the tangent. Right, there's the tangent to that point. How then do we started off like this, how do you find the gradient of the tangent?
Rise over run.
Rise over run again. So we would just take points I know from that tangent, might just go across, and it's going to be an estimate because my tangent might not be great, but I do the same thing, and I do change in D and change in time, and I'm doing dd dt. Now, after we've done a bit of optimization, we're going to be looking at these, because this kind of situation we are looking at gradient and dy dx or dd dt, a lot of it, as a rate of change. So can you see that by doing the gradient at this point, we are looking at how quickly does distance change given a specific time, yeah? So if the gradient is steeper, we have a higher rate of change. So we are going to be looking at rates of change as the next bit after optimization. And it's just about, you're probably going to find it easier than the optimization bit because I did skip it to do the optimization. We'll go back, so you'll find it a bit easier. All right, okay, so that's what we're going to move on to. Do you have your optimization question? So we had one final question to go through. Right. So, if I asked you to summarize the optimization topic and each question we've done, if I were to ask you to summarize the skills that you need to be able to do, what would you tell me?
Know how to use formulas.
So think the first thing they're going to ask me to do, the second thing they're going to ask me to do, the third, it's always the same. Different formulas maybe, but usually the same principle. What would be the first thing they're going to get you to do? Feel free to look at the questions we've already done that. Pardon?
Surface area.
It might be surface area, but what are we going to be asked to do with surface area?
The maximum.
Not yet. The very first thing we're going to have to do. So always the first thing you tend to be asked to do is to derive the formula for something, whether it be the surface area, the volume, just the area of a base or something. Do you remember the cylinder one was surface area? The tray was the volume. You had to derive a formula for either surface area or volume. What's the next stage? So once you've derived the formula for volume, let's say, you're going to be asked to do what? But what is the thing that leads us to that point? Because that's the final thing.
You need the gradient.
The what?
The gradient function.
The gradient function. Yeah. So you're going to be asked to find dv dt or dv dA or whatever it was. Yeah. So you're going to have to differentiate a function first. Then, and we haven't got Maya because she would tell me straight away. What's the next thing? So you find dv dA, and then the next thing would be equals 0. So you're going to have to solve for that equaling 0. And what does that do for you?
It tells you the lowest point.
So it tells you the lowest point of the gradient function, and when the gradient is 0, the function itself for volume or surface area will be a what or a what? A turning point, and a turning point will be what or what?
Minimum or a maximum.
A minimum or a maximum. So that's what we're looking. So we're looking for a turning point because that will be a minimum or a maximum. Now, one thing we haven't done yet is looked at a function where we are asked to find a turning point and determine whether it is a minimum or a maximum. We have talked about it, but we haven't done it in one of these. Normally, because with an optimization problem, it's quite obvious whether it's going to be minimize the surface area, maximize the volume, that kind of thing. Right? So we're going to be looking at that. When we find a certain dimension that will give us a maximum volume, what are we normally then asked to do? Find the what value? Either the or the min. So find that volume. Remember, you're being asked to, you find a volume equation, you're asked to differentiate it, put it equal to 0, because that will find one of the dimensions that will give you the maximum volume. The final piece of the puzzle will be well, what is the maximum volume? Tell me what it is. So I put it back into the first equation. So that's what these problems are all about. It goes back full circle. That's what. So they're always the same. You should be expecting that to happen. So let's look at this. A shipping container is made with 6 rectangular faces. Dimensions are 2x, x, and y. All of the measurements are in meters. The total length of all edges is 48. Okay, and this is it. Do you notice they always have a show that? Because if you can't show that, you can still do the rest of the question. All right. So there's a good few marks available. So 3 marks for showing that. Now, there's always a clue in how to start with the show that. What do you think it is in this case?
They gave you the length of it.
Okay, so the piece of information they've just given you is the total length of all the 12 edges is 48 meters. They've given you that for a reason. They want you to use that piece of information. So, what do we have? So on my diagram, my 12 edges are, well, that's x, that's 2x. This would be y. This one would be 2x. This one would be x, 2x, x. Okay, and then this one would be y. And then what am I missing? So I'm going to have these here. So that would also be a y. This would be an x, and this would be a 2x. So I just need to check I've got them all. So, what do we do then? Bit of exam technique, make sure you don't miss anything out.
Add them all together.
Add them all together, cross them out when you've done. So 2x, add 2x, add 2x, add another 2x. Okay, so I've done those 4. Then I've got this. I'm going to add x, add x, add this x, and add that x. And I'm starting to see the pattern now, so then the others will be, there will be y's, and there will be 4 of them.
You did a y up there.
Sorry, I was already thinking of the y's. So that y, that y, that y, and that y. Now, have I done all edges? Yes, I have. So what do I then end up with? Well, that's 2, 4, 6, 8 x's. This is another 4 x's, and this is 4 y's. So in total I have 12 x's and 4 y's. And what am I told? That is equal to 48. Okay. Now I'm not quite yet at the point where they want me to be. So, how do I get from 12x plus 4y is 48 to y equals 12 minus 3x? Well, yeah, it's kind of factorising, yeah. We can take a factor of what out? 4. So why don't we divide through by 4 on both sides, and then I get 3x and 1y, and that equals 12. So I'm almost there. So all I've got to do now is?
Minus y and add 12.
Well, I don't want to minus y, I just want to
Minus 3x.
minus the 3x. And then I end up with y is 12 minus 3x, which is exactly what they wanted me to do.
Where did 48 come from?
In the
Oh.
that bit. So with these questions, this is the important bit. This is the bit to take note of. That little piece of information they give you. Because if they didn't give you that focus, it would be very difficult to identify how they've got to the formula that they want you to get to. Because you would say, well, is it a volume one? Is it a length one? Is it an area one? I don't know. So what we do is we take the information, the total length in that statement, and that's what we then do. We work from that statement. All right. Everyone clear on that? Good. All right. So show that the volume of the container is given by that one. So how do I work out volume? Volume of a cuboid. Length times width times height. So I know that length, width and height, so it's 2x times x, 2x times x times y. Okay? Which is 2x squared times 1. Now, is that what we have? Is that where we need to end up with? No. Now again, we take the clues. Why did they want us to do part A? Because A is y equals 12 minus 3x. This has no y's in it, therefore we need to replace this y with 12 minus 3x. So we've got v equals 2x squared times 12 minus 3x. So that would be one of those two marks, and then the second mark would be expanding the brackets. So that would be showing that we've got v is 24x squared, and then that would be minus 6x cubed. How do you feel about that bit so far? Alright? Just to let you know, last year I had my SL students doing a very similar question, and they found it difficult. You know, so if you are finding it difficult to follow it through, it's not easy stuff.
This makes a lot more sense than we were doing before.
Yeah? Well, I think that's just because you're getting used to it. I think if you went back and did the other ones, you'd find them easier as well. So, the next phase is find dv dx. So we've done that. dv dx. So if that's v, dv dx will be, anyone want to tell me?
48x.
48x
x squared.
There you go. 48x minus 18x squared. Alright. So that's that done. Right. Now we've got to find the value of x for which v is a minimum. Oh, sorry, maximum. Because we want to maximise the volume. Right. Do you understand what's happening here? So there are certain things that have been set in stone, such as the box has to be twice as long as it is wide. That's why we had the 2x and x. Right. So that's a rule set in stone. So we are then trying to say, well, what is the biggest box? If all the edges add up to 48, what is the biggest volume I can make with those rules? So the edges have to add up to 48 and the length has to be twice the width. So now let's find the maximum. What would x be to make that? Now if I said that just to you, a month ago, you'd be doing some trial and error method. You'd be going, okay, well if x is 1, 2x would be 2, and then y would have to work it all out. So we're trying to avoid that now. We're doing it in this method. So what do we do? What's the first statement we make? So if we want to find a value which v is a maximum, we have to do?
Make it equal to 0.
Equate it to 0.
Equate it to 0. So we have to do 48x minus 18x squared equals 0.
I said that.
Did you? I just didn't hear, sorry.
I said it quiet.
You just said it correct. Okay. How are we going to do that?
Graph it.
Wait, are you?
We could graph it.
We
Yeah.
could do the algebra. We don't have really hard.
Do polysymbol as well, I think, maybe.
Do you have a grid?
This one's actually not too hard. I could actually probably do this one factorized form.
Yeah.
So if I took a factor of 2x out, or 6, yeah? 6. Take 6x out, what am I left with there?
8.
So that would be 8 minus
3x.
3x has to equal 0. So this would then be, do you know how to do the null factor law thing again? So either
Oh yes.
6x has to 0, which means x equals
0.
0, or
8 minus 3x.
which means that 8 equals 3x,
Yeah.
which means x equals
8 over 3.
8 over 3. Which one is it going to be?
Well, x can't equal 0.
X can't equal 0 because you don't have a box. So that would be important. We would know to cross that one out. Do you want to just have a quick go at confirming this is true with your calculator? Just so we've got both options, just in case you try and do it algebraically and don't quite, you're not happy with whatever result you come up with.
Question.
Yeah.
How did we get dvdx?
So 2 times 24 is 48, and then take 1 off the power. 3 times minus 6 is minus 18, take 1 off the power.
Wait, no, not yet. Just
Yeah. So on my calculator, I'm going to put in 48x minus 18x squared. Oh, that's the wrong button. Can't see. I should look on this. Oh, what's going on? Okay, so I've got that, and I'm going to graph it. Here's my graph. So I would expect that because I'm expecting a maximum. Now, I can't see it very clearly. I don't really need to, but
I changed the 16.
I'm just going to click zoom, and I'm going to zoom in, and I'm going to move my dot, my cursor, to the area I want it, just sort of in there,
That's my experiment.
and it's going to do that for me.
That's why
It's probably in this optimization one a nice easy way of doing it. And so here are my two solutions. I want where it equals 0, so that's here, which is the x equals 0 option, which I'm not interested in, right? And it's here,
I got it in post.
right? And if I do second calc 0, I'm going to go left of that one, and I'm going to go right of it, press enter, guess enter, and it gives me 2.6667, which is 8/3. Okay. I can't do the Polysymot on this, it doesn't have that app, but have you tried it with Polysymot on your calculator as well, just in case you can?
No. Oh my god. So that's the answer?
I've done that. What did you put for your YX?
I just press zoom in, actually.
Originally, what did you put in? Like 48?
Yeah, I put in dvdx. I want to know when that's equal to 0, so 48x minus 18x squared. So what you need to be clear of with stating your answer that x equals 0 is not a solution. So if you state it, you need to cross it out. So we've got 8/3. Yeah? No?
If you do it on Polysymot, make sure you do -18
Yeah.
as your first option. Thanks.
I don't understand how I should determine what x values and y values to put in.
Yeah.
What do you mean, which x? For the window?
Yeah.
I just want to see the graph. To be honest, it's a bit of a trial and error for me as well.
Interesting. Yeah, but how do you even get, like, how do you,
Well, like I think I've said before, if it was, let's say for instance, let's say I've got my setting at -10 to 10. It's like the default setting, isn't it? -10 to -10. Oops, sorry. Right. If I were to do that and graph it, I've got that on my screen. Now, what do you do? Well,
You can see that.
I need to see higher. How do I see higher? I have to change my y max to a bigger number. So I could go, let's try 50.
yeah, I was 50 and I could see it.
Right, now I can see that. So I've just guessed, that's fine. I actually only need that point. I don't need to do any more, but if I wanted to make it a bit nicer, I want less y. So what I might do is say, less x. I don't need -10. I might just go
That's why.
-2. And then I didn't need all the way up to 10, so I might just stick a 5 in and graph it. It's a bit of trial and error. It's just like, how does it fit? So I've got that.
Can you show
Thank
me
you.
one more time how you got the value with the, like, left and right hand?
Okay, so I want to find that point there where it crosses. That's when it's
So you
equal
don't
to
try
0.
Find the arc.
No, because I need to know when this function
Uh-huh.
equals 0. So when it equals 0, it's on this line.
Great.
That would be a mistake that people might make. They go, oh, I'm trying to find a maximum. So they would do that, put it in their graph, and then try and find that point. But you kind of need to understand we're actually looking for the equals 0. So it's an important point. So I want to find equals 0. So we have on our calculator, under second and calc, 0. So we go to 0 because we're trying to find an equals 0. And I know it's this one, so when it says left bound, what it means is we go to the left of that point. So I am still to the left. I'll press enter. It doesn't matter where to the left. There's no direct place I have to be. But you'll notice it puts an arrow pointing that way. Because now it tells me, right, go to the right of it. So if I go to the other side, again, it doesn't matter how far, and press enter, you'll notice there are 2 arrows facing each other. So it will only look between those 2 arrows. So imagine a So I think on yours, the nice ones, they put dotted lines, don't they? So it will only look between those two lines for a place where it equals 0. So that's why it says guess. Now what you could do is go back up to near it, but you don't really need to. I just tend to press enter, but do that and it tells me the x value. Now we should check. It says y equals 0, which is what I want. Yeah? So we use that an awful lot. Right, so we've got this. We've found the x for which v is a maximum. Now don't forget, x is just that value, the width. That would mean the width is 8/3, but the length is 2 times 8/3. The height, I don't know yet. I could work it out, but I don't know. I've only figured out x. But actually, I don't think I even need to know that, because it says find the maximum volume. And we have a formula here in x for volume. So if volume is 24x squared minus 6x cubed. Now we have to be careful not to use dv dx. We are using v now. That's why I said before, you always go back in full circle. You go back to the volume, and we use x is 8/3. Now, what's the easiest way of doing it? So I've got to do v equals 24 times 8/3 squared minus 6 times 8/3 cubed. What's the easiest way of doing this? To figure out that value. What is v? Just put it in my calculator, yeah? But there's different ways to do it. Now I could do it like this. If I put in y equals, I'm going to switch that one off just in case I want to check later. And I'm going to put my volume equation in. So 24x squared minus 6x, and it's to the power of 3. If I then graph that, right, that's what that graph looks like. What I can then do is go to second and calculate and put a value in of, well, I can do it like that. 8/3. Oh, I think it doesn't like that, does it? So 8 divided by 3. If I press enter, I get 56.89. It does it for me. I don't need to. I could write it out in the other way. I could do it as 24 times, put it in as a thing, 8/3 squared. I could do that if I want. Keep going. Minus 6 times, just to show you we get the same thing, so whatever you fancy doing, 8/3 to the power of 3, and get enter. But this time I get it as fraction, because I put fractions in. Right? 512 divided by 9. Right? So 512 divided by 9. Oh, it's close now, aren't you? 512 divided by 9 equals 56.89, just like I had before. So 56.888, which would be 56.9. And again, what do we need to make sure we have at the end?
Units.
Units. Now, do we have any units?
Yes.
Meters cubed. Look. So we need to make sure that I put cubic meters as my answer.
What's the parts for the graph? What did you do after you got it?
Okay, so my graphing methods, I just went to second calc value, yeah, and put 8. just put 8 divided by 3. And that's by far the quickest way, isn't it?
Yeah. Oh wow. Okay,
Yeah.
thank you.
Alright. So find the length and height of the container for which the volume is a maximum. So we know x is 8 over 3, and we know 2x is then 16 over 3, 2 lots of 8 over 3. You're okay with that? So 2 times 8 over 3. We don't know what y is, which is it says find the length and height. So we've got the length, that's what we were told, but we've got to find the y, the height.
And y 12 minus 3x.
Say it again.
Y is 12 minus 3x.
Y is 12 minus 3x. Why'd you say that?
It tells us that.
So it does, doesn't it? We've got y equals 12 minus 3x was an equation we had. So we've then got y equals 12 minus 3 times 8 over 3. So that would be 12 minus, well, do you all know if I do this, 3 times 8 divided by 3 is actually 8. 3 times 8 divided by 3. So it's 8 divided by 3, then times 3, you get rid of the 3s, yeah? So that times by 3 is cancelled by, so we've actually get y is 12 minus 8, which means y is 4. Nice and easy.
What's, oh no,
That one.
never mind, I see it.
So we actually didn't need to worry about that because we just needed that one, and then we needed this formula for y. That there's another way. There was kind of the volume is 56 point whatever. You know, we know 1, 2 dimensions we could divide by, but that would be a longer method. We don't need to do it. Can you see, by the way, how we could have made our lives an awful lot more difficult if at, where would I say, you know, when we had to solve this, if I'd have written down 2.67 instead of 8 over 3, can you see how using the fraction has made it easier here? Much easier. Otherwise here I would have had something a bit different. I'd have had a decimal here too, which they would have probably accepted, but they're hoping for you to keep it as 8 over 3. So if you'd have done the calculator method and got 2.667, fine, absolutely fine. You'd have ended up with a slightly different answer for y equals 4, but if we'd done the algebraic method here, we'd have ended up with 8 over 3. But if you do that and get 8 over 3, leave it as 8 over 3. Don't turn it into a decimal that you have to round. Okay. Finally, the shipping container is to be painted. 1 litre of paint covers an area of 50. There's a lot of marks here for this final bit. This would be like final question in the paper. The amount of marks in it. 1 litre of paint covers an area of 15 square metres. Paint comes in tins containing 4 litres. Calculate the number of tins required. So what do we need first?
Surface area.
We need to know the surface area. So what do we have? Our surface area is, well, it's x by y would be one side, yeah? I'd have another side that is 2x and y, and I have 2 of them and 2 of them, yeah, on either side. And then on the top I would have a 2x by x, and that would be on the bottom as well, yeah? So I'd have 2 of those. Does that make sense? So I have a value for x and I have a value of y. So that would be 8 over 3 times 4 times 2. This would be 16 over 3 times 4 times 2. Pardon? What's up? Nothing? And this one would be 8 over 3 times 16 over 3 times 2. So that would tell me my total surface area. Now, regardless of finding the numbers may be a little bit hard, do you all understand what I've done there?
No.
Where the numbers come from?
No.
No? So all that parts before were to work out x, 8 over 3. And what I've done, I've got to find the surface area of this box. Yeah? So if I just rub out all my marks, just to make it a bit clearer, I know the surface area of this box. So I've got an x times y, and I've got 1, and then there's another one on the other side. So there's 2 of them. That's why I did the times 2. So that's the x times y. Alright? And then this side is the 2x times y. And there's 1 on the other side there as well. And then the top is 2x times x. And there's 2 of them as well. So I've just taken every face. And I've worked out already from the questions, x is 8 over 3, y I've worked out as 4, so I've just put all of that in to my surface area. So has anyone worked out what that is? You've got to add all that together. So what's my surface area? Well, I guess 2, 16, 8 times. So that would be 64 over 3.
The format is confusing. All you know.
Well, they're just my faces of the box, laid out, separated.
Okay, what did you make
That
it?
equals
What did you make it
64
out?
total. On both sides. The answer
Sorry, I will listen. Sorry, I'm trying to get it. Right, so this here, these 2.
Yeah, I understand where it came from, but I don't. Where is it on this? Why isn't it crazy?
I haven't done one yet. I'm just working out each one separately. So that would be 64 over 3. There's no x's and y's because I know what x and y is now. So I've replaced the x's and y's with the numbers. So y is 4, x is 8 over 3, and there's 2 of them. Yeah? Okay, sorry. What did you say, Carla?
So the other side adds up to
128 over 3.
And that equals 64 overall.
Sorry, what this? Have you done this one as well?
No.
So this added together is
Both of those added together is 64.
just 64. Okay. And then this final bit that I need to have as well, the top one.
And I just use
16 times 16. Yeah.
is 128 over 9.
This is 128 over 9. So I've then got to do 64 plus 128 over 9.
I got 256. Yeah, I got 256
Did you?
over 9.
Okay.
Oh, oops, I put never
Forgot
mind,
the 2.
I put in
So 256 over 9. That looks better. So 64 add 256 over 9 is 832 over 9. Okay. So it says 1 litre of paint covers 15 square metres. So this we have as square metres there. So we need to figure out how many litres of paint we'll need. So does it make sense then to do,
So we need 93.
so we've got 832 over 9 and we divide that by 15, is that what you say? Yeah? Are you all okay with that? Just have to figure out how many lots of 15, that's a...
7.
So what is it?
I see the guy that just lost. Well, if you divide it by 15, it gives you
6.16. Do we all agree? I'm not working it out, so I'm kind of relying on you all to be doing it and checking each other. Do you agree? Yeah, Anna agrees. So 6.16 litres. Alright, and we've got our final thing that then says paint comes in containing 4 litres. So calculate the number of tins required to paint the container. So how many tins do we need?
2.
2 tins.
How do you get 2?
Because each tin has 4 and I need 6.
Each. Oh.
Yeah. So I have to buy 8. Because I can't, 4's not enough. I can't buy 6. I can only buy 4 or 8 or 12. Or, so we think 2 tins.
So what if you just put 6.16 liters? You wouldn't get the full amount.
No, because the question is how many tins. You'd get some. You'd probably, by that stage, get 3 out of the 4. Yeah. Alright. Long question. I think, is that a 23 mark question? Okay. Right, here's the thing then. This was going to happen, so we've got 5 minutes left. Right, so we've kind of done 3 very big, complex, long optimization questions. That's basically the limit. That's where you need to aim to get to. All those 3 questions. So you've got those solutions we've been through. Now, if you turn to page 599 in your textbook, you will see the optimization chapter. Right? And it talks about the diagram test, whether it is a maximum or a minimum. We did talk about it if gradient goes from negative to positive and so on. Right, you've got those in your notes, right? And then it's all about optimization problem. Now, if you look over at example 7 on page 600, you will see a very similar question to we've just done, only slightly simpler in that it's a square-based box. All right, and it's got there this step 4 I'd like you to take a note of, which is a sign diagram test, and it's to test whether it is a maximum or a minimum. Now, for me, for you guys, for a problem like this, you are going to know if it's a maximum or minimum. But if they were to say to you, show that it is a maximum, you would have to do that test. So have a read through the example.
You couldn't just graph it?
Well, it's that show it is. So there's two ways. You could do the diagram test and show that's what they're hoping, that you work out the gradient either point, either side of the point, or you could get away with sketching a graph and showing it's a maximum, I think, as long as the values are labelled. Right? Now, what we are going to do is because we've done about three lessons, I think, on just optimization. Next lesson we need to get back. Well, if you turn back a few pages to page 594, you'll see what I'm talking about, the rates of change. That's what I need to do with you next, right? Before we can have an assessment on this after the Christmas break. Well, I just don't think we're going to get it in beforehand, right? What you are going to need to do then, if we're moving on to rates of change, you are going to need to, well, if you are perfectly happy with what we've done, then fine, you probably don't need to do an awful lot more, right? If you feel I need some practice on that, there are a lot of questions here, starting with the basics, moving on to harder things, right? Lots of them. Lots of possible questions there, alright? It's kind of up to you to work through them. Now, if you turn up to a lesson and say, I've been trying this question, I'm kind of stuck at this point, can we go through it? Fine. I'll happily do that, because it's a tough thing. If I don't get that at the beginning of a class, then I'll just carry on with rates of change and so on, and then we'll get through to finishing the course. We may, I don't know, we'll be finished the course pretty soon after Christmas, which will be nice. Right? And then we've got a long time to revise and go through everything again. Yeah? It does sound good. Right. I need to check that. Okay, that's the plan of action.
Thank you.
Have a good night.